My name is Myles Henderson, and this is my research proposal. Essentially, we are trying to improve muscular strength without you actually having to contract your muscle. Now, this is a fascinating research because we are using a tDCS-Enhanced action observation motor imagery training protocol and seeing the effects on hand grip strength in older adults. So what does this mean? The tDCS is a transcranial direct stimulation. Essentially, we are stimulating parts of the brain and enhancing that function of that part of the brain. For the action observation motor imagery training, we will have a VR headset and the participant will watch an actor do a task and then the participant will mentally rehearse that task in their head. So imagine you're watching LeBron James shoot a basketball and then you mentally rehearse yourself shoot that basketball. In time, you will get better shooting that basketball. That's essentially what we're targeting with that tDCS intervention. Now, hand grip strength is seen as a key biomarker for future health outcomes in older adults. There was a longitudinal analysis done in the UK which revealed that hand grip strength is strongly associated with diseases such as dementia and Alzheimer's. With the expected number of adults to double by 2050, there is a growing need to explore alternative strategies that preserve neuromuscular function in older adults, potentially minimizing the risk of these diseases such as Alzheimer's and dementia. For this study, we will be targeting the prefrontal cortex of the brain. Studies have shown that the prefrontal cortex is strongly associated with motor coordination. And as we age, we rely more on the prefrontal cortex for this motor coordination. We will be doing this by having 4 different groups with 12 participants in each group. We will have our control, our action observation motor imagery only, our action observation motor imagery plus our tDCS active, and then which is our experimental group, and then action observation motor imagery plus our tDCS sham, our placebo group. So we will not be giving an electrical current for this group. During this study, we will have the participants come in for 2 visits. During visit 1, we will assess movement imagery questionnaires and cognitive status questionnaires. During visit 1 and 2, we will do grip strength protocol assessments as well. What this grip strength protocol looks like is right here. We have a dynamometer right here set up in the participant's dominant hand, which records force output in kilograms as the participant maximally contracts. We also have an EMG sensor placed on the flexor digitorum superficialis, the muscle used to contract the hand. As the muscle contracts, we are able to record the electrical activity that gets sent from the brain to the muscle. We can further analyze these signals and see the individual motor unit characteristics within the participant. Now, since this is a proposal, we have actually collected some preliminary data which has shown us some good results. What we can see here, just a preference, is that with the black line, we have the motor unit characteristics before the intervention. The gold line is going to be after the intervention. And the individual dots are just the motor unit characteristics that we recorded. What we can see here with the action observation motor imagery only, the VR headset, we actually see a slight increase in neural drive and motor unit characteristics. When we look at the grip force, we actually see consistent measures pre and post following the intervention. Compare this to our placebo group, we see very consistent metrics. We see that slight increase in neural drive following the intervention with the placebo group. We also see consistent grip force measurements as well. Now, what's interesting is that for our experimental group, the active tDCS, we actually see a decrease in neural drive. We also see a decrease in grip strength performance as well. What's interesting about this participant is that they scored a 2 out of 7 on their movement imagery questionnaire, which assesses the participant's ability to mentally conduct a task. So this begs the question, if this participant scored better on this movement imagery questionnaire, again, their ability to mentally conduct a task, would they have performed better with our intervention? Now, this is exciting news because we're actually able to see an exaggerated change following the intervention, which means that there is change within the variables pre and post intervention. Since I just want to preference, since this is a preliminary study, we will be collecting more participants, which will give us a better idea of this data. This is extremely important because every single day there are 10,000 Americans turning 65 and older, which shows that there is a growing need to target alternative strategies to preserve neuromuscular function, potentially minimizing the risk of diseases such as Alzheimer's and dementia. Thank you.